A wave is a kind of oscillation, which is accompanied by a transfer of energy that travels through a medium. Traveling waves can carry energy through a medium from place to place. For example, if you have a stretched out string and you oscillate one end, waves will travel on the string from one end to the other. Waves on a string are pretty easy to visualize. Other kinds of waves are more difficult to picture in your head, but if you can understand the properties of waves on a string, you'll find that a lot of what you've learned can be applied to other kinds of waves as well. Sound is a wave which travels through the medium of the air. Light is also a wave, but it's a very different kind of wave than sound. Light is a type of wave called an electromagnetic wave, or EM wave for short. In this video, I'll give you an overview of what EM waves are and why it's important to know about them. In an EM wave, instead of particles in a string oscillating, what oscillates are the electric and magnetic fields. When the electric and magnetic fields inside your eye are oscillated at just the right frequency, your eye detects that, and you can see. So, there are actually two media for an EM wave, which work together: the electric and magnetic fields. But what is a field? Well, in physics, a field is one way of delivering a push or a pull at a distance. The electric field, for example, pushes and pulls things that are electrically charged. The magnetic field pushes and pulls things that are magnetized, like magnets. These fields exist everywhere in the universe. That's why light and other EM waves can travel through the vacuum of space, where there's nothing, not even air. Electric and magnetic fields exist at every point in the universe, so they can always support an EM wave. EM waves all travel at about the same speed, which is incredibly fast. It's called the speed of light, and it is 300 million meters per second. How fast is that? Well, light could travel all the way around the Earth 7 times per second. This is so fast that from the everyday human perspective, EM waves travel from place to place almost instantly. Like other traveling waves, EM waves carry energy from place to place. For example, if you stand outside in the sunlight, energy is being carried by EM waves from the sun across the vacuum of interplanetary space to your skin, where it is absorbed. And that's what heats you up. EM waves can be sine waves, which have a frequency and a wavelength. Just like with other sine waves, if you multiply the frequency times the wavelength, you always get the wave speed, which, in the case of EM waves, is the speed of light. The different colors of light you see are all different frequencies or wavelengths of EM waves. Here's a list showing the colors of the rainbow and an approximate frequency and wavelength range for each color. You can see that as you go up from red to violet through the colors of the rainbow, the frequencies get higher and higher, and the wavelengths get shorter and shorter. Red light has the lowest frequency we can detect with our eyes, and violet has the highest frequency. The frequency of oscillations of the light we see is very high. So in this list, frequencies are measured in terahertz, where 1 terahertz is equal to 1 trillion hertz. The wavelength of light is very small. In this list, wavelengths are measured in nanometers, where 1 nanometer is a billionth of a meter. When you combine the frequencies of all the colors of the rainbow, our eyes interpret this as white light. White light is an even mix of all the frequencies of EM waves that our eyes are sensitive to. It turns out that there are other kinds of EM waves other than just light. They are all classified based on their frequency or wavelength range. Going from the lowest frequency kind of EM wave up to the highest frequency, they are called radio, microwave, infrared, visible light, ultraviolet, X-rays, and gamma rays. You've probably heard of a lot of these kinds of waves, but you might not have realized that they are all different manifestations of the exact same kind of wave. They are all EM waves. The only basic difference between an X-ray and a radio wave, for example, is their frequency. The frequency of an EM wave has a big effect on how it interacts with matter and how we can detect it. For this reason, different kinds of EM waves are known for very different things. Very high-frequency EM waves, such as ultraviolet, X-rays, and gamma rays, can be harmful to our health, since the frequencies are high enough to cause chemical reactions inside our cells. Only visible light can be detected by human eyes. For the other types of EM waves, we must use special detectors or antennas in order to detect them. EM waves can sometimes travel through matter, depending on the type of matter and the frequency of the EM wave. For visible light, a piece of wood is opaque, and a piece of glass is transparent. That means that EM waves at the frequency of light can travel through glass without much dissipation of their energy, but they get absorbed right away by wood. For other frequencies of EM waves, different materials are transparent. For X-rays, for example, soft tissues in our body are mostly transparent, but our bones are opaque. So, if you have a source of X-rays on one side of your body and an X-ray detector on the other side, you can take a picture of your bones. For radio waves, almost everything is transparent, even a thick brick wall, and even you. In fact, if you live here on Earth in the modern day, you will always have radio waves passing through you in all different directions. Since radio waves travel so fast through so many barriers, they are very useful for communication. There are many different frequencies of radio waves, and they can be used to transmit all kinds of information, including music from radio stations on the FM and AM frequencies, phone messages and other data over the cellular frequencies, and the internet over what are called WLAN frequencies. All of these are EM waves, and I hope you can see they are truly essential for our lives.